All right. Hi, everyone. My name is Bernd, and today is day 11 of Advent of Code. Today's puzzle was a map-based puzzle again. So we got an input grid just like this, and here the dots correspond to empty space, and the number symbols correspond to galaxies. And then what we want to figure out is the shortest path between every pair of galaxies. There's some catch from the input, so the input is not exactly the galaxy positions, but in the input there is some empty rows and some empty columns, and whenever there's an empty row, we're supposed to add another row to find the real positions of the galaxies. And yes, how can we do that? So this time again, reading the input, of course we need, and passing the line was relatively straightforward. And then we want to know how we want to get the galaxy positions based on those original occupied positions in the original input. So for that, we first get the set of x coordinates, and then we want to figure out the empty columns. We do this by considering all the indices which are not in the x coordinates. This will give us the empty columns. And then what we figure out is a list of values which always give us the number of empty columns before a particular index. We get that using this getCounts function. So if we have a list of indices and a particular length, we will go iterate I up to the length, and then we check if I is in this set of indices. Then we will increment the current count, and anyway, to this list of counts we'll append the current count, so that at each particular index it gives us the number of indices before. Okay, so we do the same for the y coordinates. We consider the set of y coordinates, use that to figure out the empty rows, and use that to evaluate this list that always gives us the number of empty rows before a particular index, and then that will allow us to get the galaxy positions. So we start with an empty set, then we go through all the occupied position, and then the x-coordinate of the galaxy will be the x-coordinate of the occupied position plus the number of empty columns before this coordinate. Similarly, the y-coordinate will be the y-coordinate of the occupied position plus the number of empty rows before this particular coordinate. And that will allow us to solve the problem. So in order to do that, we first parse our lines to get the occupied position. Then we get from that, we calculate the galaxy positions, and then we'll get the pairwise distances. And this value will have all the pairwise distances twice. So we divide the sum by 2 in order to get a puzzle solution. The function to get the pairwise distances is also relatively straightforward. We go through all the position, iterate for all the positions twice, and then calculate all the distances between this pair of positions, and that is done by just considering the absolute difference between the x-coordinates and add the absolute difference of the y-coordinates. All right, so we should probably run this solution on the test input, and it turns out fine. So we also run it on real input, and it turns out it gives us the right solution as well. For part 2, it turns out that each empty row does not turn into 2 empty rows, but many more. So it will turn into 1 million empty rows. And in order to add that to our code, we slightly adapt this getGalaxyPositions function to also accept an expansion factor as an input. And then what we'll have to change are these 2 lines. So now the galaxy x-coordinate will still depend on the original x-coordinate, but this time we have this factor in front of this empty columns before x number. So the factor will be, we have a -1 here because 1 empty row will turn into that many empty rows, but one of them is already counted in the x-coordinate, so that we'll have to subtract here again. And with that we can solve the problem pretty much as before. We find the occupied positions, we find the galaxy positions, this time taking the expansion factor into account, and then we get the pairwise distances, and that allows us to get the solution. We're known for our original input for 2 different expansion factors what the solution is supposed to be, so we check whether that actually works, so that's nice. So we can also run it on the real input, and that turns out it also gives us the right solution. All right. That's it for day 11. I hope you enjoyed today's puzzle. Best of luck in the future, and I will see you around.